Hello student, I am Mrs. Shweta Shailendra Pandare, Assistant Teacher, Vidyapit High School, Kolhapur. Next point, force acting on current carrying conductor in a magnetic field. Next point or activity, force acting on a current carrying conductor in the presence of magnetic field. So current carrying conductor is copper wire and the magnetic field, that is, this is horseshoe shaped magnet, and for this experiment we need stands, then horseshoe shaped magnet, copper wire, and also some components, that is battery and plug key. So arrangement of these, that is the copper wire to the battery, and then whenever that current is not flowing through this wire, it remains straight, that is, here is the positions of this wire. Hence when there is no current flowing through the wire, it remains straight, means position A. When the current flows from top to bottom, the wire bends and comes in the position C. So this is the direction of the current, that is when current flows from top to bottom. Then let us see, this is the straight position, but when current is passes, then in this current carrying conductor, that is a copper wire, also having a magnetism, and this we place in the magnetic field of this horseshoe shaped magnet. So let's see in the figure, this is horseshoe shaped magnet and this is the current carrying conductor wire, and when current is passed through this, then this also having the magnetism. So the position C, that is when current flows from top to bottom, wire bends and come position C. If current direction is reversed, that is current direction, it flows from bottom to top. Let's see the position from bottom to top, and the wire bends comes in the position B. This means the direction of force on the wire is perpendicular to both magnetic field and the direction of current. Here we change the direction of current. First from, that is, top to bottom, and then bottom to top. So there is also, we can see the change in the force, that means the direction of force of wire is perpendicular to the direction of the current. Here the direction of magnetic field, let us see here direction of magnetic field, that is north, here pole and here south pole. So they are given here the arrow. This is that the direction of magnetic field is from north to south. In this experiment, it is noted that whenever current flows through conductor, this is copper wire is a conductor, and when current flow through the conductor in the presence of magnetic field, a force is exerted on the conductor. So this is the area of magnetic field of this horseshoe shaped magnet. We place this current carrying conductor in this magnetic field. Hence, whenever current flows through the conductor, we start the current through this conductor in the presence of this magnetic field. A force is exerted on conductor. So, on copper wire there is force is exerted. If the direction of current is reversed, the direction of forces also get reversed. That we seen in this the experiment. But if magnet is kept reverse, that is, first position is here is north pole, here is south pole, but when we reverse this position, that is, south pole is brought at the position of north pole and its north pole is brought at the position of south pole. What will be happen here? Let's see here. That is, position of these the poles are get changed. Then the direction of force will be also reversed. So by this experiment it is clearly shows that force is exerted on current carrying conductor, that is, the direction of this force is depend on both, that is the direction of current. Here is shown the direction of current, that is from top to bottom and bottom to top, and also the direction of the magnetic field. It is shows that this force is maximum when the direction of current is perpendicular to the direction of magnetic field. So by this activity, let us learn a next law. Fleming's left hand rule. In above experiment, we considered the direction of electric current and the direction of the magnetic field and formed that the direction of the force exerted is perpendicular to both. Perpendicular to both, that is, this force exerted on current carrying conductor is perpendicular to the magnetic field. This is magnetic field, so this is perpendicular to this, and also that force exerted is perpendicular to direction of the current. This is the direction of current, here is perpendicular to this also. There is a simple rule relating these three directions. This rule is called Fleming's left hand rule. According to this rule, the left hand thumb, index finger and the middle finger. So this is left hand, thumb, then index finger and the middle finger are stretched so as to be perpendicular to each other. See the position. This is thumb perpendicular to the index finger and also this is perpendicular to the middle finger. So this is the position of left hand. Then if the index finger is in the direction of the magnetic field and the middle finger points the direction of current, then the direction of thumb is the direction of the force on the conductor. Again see that is the positions of the fingers, that if the index finger direction of the magnetic field, this is the direction of magnetic field, and middle finger, that is points the direction of the current, then if the two fingers are in this position and shows the magnetic field and the direction of current and the direction of magnetic field, then the direction of thumb is the direction of force on the conductor. So you by heart this law and also see the figure of this law. In this figure also they are shown the law, that is, this is the direction of the current, this is the direction of the magnetic field, then this is the direction of the force on the conductor. By this law, next, that is, on this principle there is the many equipments are working, so that we are seen in the next.